My name is Emily Russ, and I am a fourth year PhD student here at the University of Maryland Center for Environmental Science. And I'm at the Horn Point Laboratory in Cambridge, Maryland, and I study sediment dynamics in the Chesapeake Bay. Specifically, what I'm studying is where does the sediment come from and where does it go in the Chesapeake Bay. Sediment is considered one of the main pollutants contributing to water quality degradation in the Chesapeake Bay, and it's been one of the main reasons that we've developed the total maximum daily load by the Chesapeake Bay program in order to reduce the amount of sediment that comes from the watershed into the Chesapeake Bay in order to make the water fishable, swimmable, and all the things that we want to use it for. And another reason that sediment can also contribute to water quality degradation is that it often has nutrients attached to the particles, and nutrients also contribute to water quality degradation. So it's a really good idea, well, it's really good to know where is the sediment coming from so that we can better manage how to reduce the amount of sediment coming from these areas that are more prone to erosion. And to understand where it goes, that just has implications on what the fate of these particles are. Geology was probably one of my favorite subjects going from high school into college, and I knew I wanted to pursue that side of things, and I also really liked the beach, and so the sedimentary geology really fit well in all of my interests, and then I've just continued on that path and gotten more and more involved in the sediment side of things. Sediment can sometimes get a bad reputation, but I think really it's the stuff that's attached to the sediments that are more of the problem. So sediment's going to naturally settle out unless there's something else like affecting it. Like if there's a lot of currents, that'll resuspend it and that'll make the water turbid and hard to see, and so light can't penetrate it as well. But more of the problem is when there's nutrients attached to these sediments, and that can cause an algal bloom, and then sunlight can't get through there, but also these algae die, and then they sink to the bottom, and then they're decomposed by microbes, and that can consume all the oxygen from the water column and create these dead zones or areas of low oxygen. I initially, when I was looking for places to go, I didn't really have any idea of what to look for, and I ended up reaching out to Cindy. I just really liked what she was studying, and I thought that would be a good fit for me, and it would also give me a new perspective. So she works in the Chesapeake Bay, and I had mostly worked on the Outer Banks of North Carolina, so it would give me a chance to move from the beach into the estuarine environment and learn a lot of different interdisciplinary processes, how interconnected the biology side is, to the geology side is, to the chemistry side is, to the physics, and all of these things you need all of these components to come together to understand the story of water quality in the Chesapeake Bay. And I think before I had approached things from a very one discipline side of things. I was mostly just looking at the way sediments moved, and so now I understand that there's so much more going on, and that nothing is entirely dependent on one thing. Everything's connected.